Okay, so let's get into the layers of a touchscreen display. On the top, we have the protective glass. A lot of us have had a screen shatter, but think about how many times you've dropped it and it hasn't. That's because a smartphone's glass is over 5 times stronger than normal glass. And before a smartphone's glass is an aluminosilicate glass that is toughened by soaking it in a bath of potassium nitrate. This causes the sodium atoms in the glass to migrate out, and much larger potassium atoms to take their place. Because the potassium atoms are much larger, they generate a substantial compressive force on the surface of the glass. Here's a quickie. The atoms are compressed, so it would take much more force for the glass to break. Below the toughened glass is a projected capacitive touchscreen that senses the presence and location of conductive materials such as your fingertip. This touchscreen is composed of 2 transparent diamond grid patterns printed on polyester with an optically clear insulator in the middle. The diamond grid pattern is printed with a transparent material called indium tin oxide, or ITO, which acts as a conductor. Let's take a closer look on how it works. Say we build a bunch of electrons on this blue diamond. However, because there is an insulator in the way, the electrons cannot move. The electrons generate a negative electric field, which causes a bunch of positive charges to build up on the yellow diamond. This is called a capacitor. Now, when we move a conductive material such as the tip of your finger close to this capacitor, it disrupts the electric field, which changes the amount of positive charges that build up on the yellow diamond. The change in positive charges on the yellow diamond is measured, and the processor registers this as a touch. The location of the touch is detected by scanning the charges or voltage along the blue diamonds while actively measuring each yellow diamond column. Note that each row of blue diamonds is connected together. Also, each column of yellow diamonds is connected. This setup makes a grid of blue columns and yellow rows. Just to clarify again, all of these components are made with transparent materials. Measuring each point requires too much circuitry, so we only measure each column. The charge or voltage gets sent to each row in quick succession, so the processor can register multiple touches at once. Below that is a display which uses LCD or OLED technology. While the LCD and the OLED display both produce high-quality images, in this episode we are going to focus on the OLED technology as it is the standard in most new smartphones. OLED stands for Organic Light Emitting Diode. This high-resolution OLED display is what generates the high-quality images that we see whenever we look at our smartphone. This is a crazy intricate grid. Current 2018 high-end phones can have over 3.3 million pixels. That means there are 10 million microscopic, individually controlled, dimmable, red, green, and blue lights in the palm of your hand. Take a moment and think about the engineering level required to control, let alone design and manufacture, that many microscopic lights. So let's summarize. On the bottom is an OLED display composed of up to 10 million itty-bitty little colored lights. On top of that is a transparent projected capacitive touchscreen that can sense one or multiple touches at a time. And on top of that is strengthened glass that protects your screen from scratches and most falls.